Hey everyone, we're back, and recently we looked at how we can use trigonometry to find unknown lengths on right triangles, and we're going to see some application of that here. So before we begin, there are two concepts that we need to talk about, them being angle of elevation and angle of depression. So we're going to be using trigonometry to find measurements indirectly. So indirectly means we're measuring objects using mathematics. We're not actually taking a ruler or tape measure to the object. We're just trusting the math concepts that apply to the situation. So we're going to indirectly measure objects, and you'll hear words like angle of elevation and angle of depression. So angle of elevation, the best way I can explain it to you is that it is the degree that you have to look up at something. So we see in this diagram here, we're going to have a horizontal line in every single situation. So it is the degree that we look up towards our object. So our object is above us, and that angle that we have to look up is our angle of elevation. So we're going to call this line either the direct line or often the line of sight. All right, and then obviously the height of the object that we're examining would be our vertical segment here. Okay, now we have angle of elevation. We also have angle of depression. So this would be as if I'm looking out straight and then I have to look down towards an object. That is angle of depression. Notice for both situations, we are looking straight in front of us and then we're looking up or down. That's going to be important when we draw our diagrams. So angle of depression, our object is below us. And so our horizontal line is on the top. And again, we would have our line of sight. And if we were looking for it, which we probably are, we have the height, or in this case, we have how high we are above the object. Okay? So there's some connections between angle of elevation and angle of depression that we're going to be examining through this video and through future videos. But let's go ahead and look at how we can use this concept with the diagrams and combine it with our skills we were examining previously. So let's see what we have here. So from a point 340 feet away from the base of a building, the angle of elevation to the top of the building is 65 degrees. Determine the height of the building. So there will be times where we will have the diagram provided to us. So we see that here. And we can see where they place the 65, the height, and so on. But if we did not have this information, so I'm going to take this and essentially just draw it again. I'm imagining this is not there. So you'll see me often draw the building or the object that we're staring at. Okay. So you have our building, and we know very first thing is that right here, we are 340 feet from the base of the building. That is a horizontal distance. The angle of elevation, that's a key word. From where we are looking up at this degree. So it's at 65 degrees. We have a right angle at the base of the building, and we're looking for our height. Once we have our diagram, we can use the skills seen in the previous lesson, where we can just set up a trig function and solve our variable. So looking at what we have our hypotenuse, our adjacent, and our opposite. Not examining the hypotenuse, not needing it, we have opposite and adjacent. That would be tangent. So tangent of 65 degrees will equal our opposite h divided by 340. So there's two ways of solving this, two methods of thinking. So I'm going to choose to use the multiplying by 340. And in doing so, we want to make sure that, if you look carefully, my calculator's in radians. So it's right on the top of the screen, that's where we can tell. So we go to mode, we want to change it back to degree. And let's see, so we have 340 multiplied by tangent of 65. And we get approximately 729.1324 feet. And some would argue, based off this situation, you would not actually measure this 0.1324. So some would argue that it is acceptable to put 729 feet. And I could agree with that. There's kind of, it's unrealistic to measure this amount in terms of the building. All right. So we would 729. I would accept either of these for this situation. The main part that I'm concerned about, so should we, is that we get the diagram correctly, because it should make sense. If we get the diagram incorrect, how in the world are we going to get a correct answer as a result? So we can be really good at solving, but if we cannot get the diagram, then it's going to be very difficult for us. So let's try one more problem. So let's say we have, from the top of a building, top of a 100-foot tall building, a man observes a car moving towards the building. So let's see, we have a building. Okay. So he observes from the top of the building, this is 100 feet, the angle of the car is moving towards him. The angle of depression of the car changes from 22 degrees to 46 degrees. So the car is getting closer to the building. How I know that is with the angle of depression, we look straight out first, as we saw in the diagram at the beginning. And then this is the amount we have to look down. So the lesser degree says that we have to look further out to see our object. So here's our car. So car, first position. Okay, and so then the car moves. Then the angle that we have to look down at the car is greater, because again we have to look further down, it is closer to us. So this is 46 degrees. So they want to know how far did the car travel within that time. So we're looking for this distance. These problems often look very difficult, but I want to encourage you, if you see two angle measures in your problem, create two triangles, okay? So don't try to subtract or add the angle measures, create two triangles. So I'm going to take this diagram and separate it. So the first, over here, the first degree is 22, and we know the 100 feet, we're just going to shift that over to this side. All right, and then the second triangle, so our angle is larger, we're at 46 degrees. Again, height of 100. So we want this value. So when we compare that to this up here, the 22 degrees is going to get us the distance from where we are to the far end. The 46 degrees is going to get us the distance from where we are to the closer position. So we can find this value by looking for the difference of these two. So these are overlapping. If I were to subtract, we'll call this y, we'll call this x. If I were to subtract y from x, we will get the distance traveled. All right, so our answer at the end, put this here, answer at the end, will be whatever x taking away y is. So we have this, again, not having the hypotenuse. You're going to notice with our indirect measurements, we will rarely know the hypotenuse. The only circumstances where we will is if we have, we're flying a kite with a string, or we are using a ladder, or we're going up a ramp. Rarely will we have the hypotenuse. So we have opposite and adjacent in both situations. So in both situations, we're going to be using tangent. So tangent of 22 degrees equals opposite divided by the adjacent. All right, so I'm going to do my quick trick. X is in the denominator, so we divide. Denominator, we divide. So this would be approximately, let's see, notice 100 is first, so it's 100 divided by tangent of 22 degrees. 247.5087. This would be feet. I'm not going to round to a whole number until we're completely done. And then over here, let's see, we have tangent of 46 to 100 over y. Again, denominator divide. So 100 divided by tangent of 46, almost multiplied. And we get 96.5689. So our answer will be the difference of the two. So horizontally, when the car was in its initial position, when it was in its initial position, it was 247 feet from the building, and then as it moved, it was 96 feet from the building. So the distance traveled will be our difference. And we find that we get approximately 150.9398, and you could definitely argue that this is 151 feet. So when we are examining angle of elevation, angle of depression, or just indirect measurements in general, if we have two angle measures, I encourage you, look at those two angle measures as if we have two triangles. So, and find what you're looking at in each triangle, and most often you're going to be adding the two values or you're going to be subtracting the two values. So there are other ways of applying trigonometry. These are just a few, so we are going to be exploring this more, but we've just put together trigonometry and applying it to find the measurements indirectly.